Let's go over this Chapter 7 review. This will help you to do well on the Chapter 7 exam. Okay, so in Chapter 7, we talked about adding polynomials. You just can combine like terms. So when you're adding, you don't have to change anything. You just drop the parentheses, look for like terms, and start with the largest exponent we see. We talked about the degree of a polynomial. This degree of the polynomial is a 4. But I can take the negative 6x to the fourth and add it to the 8x to the fourth, and we'll have 2x to the fourth. Okay, as soon as you combine them, you can cross them out if it helps you. And then I'm going to look for the next one, which would be the cubes. It looks like I have negative 4x cubed plus negative 5x cubed. That's going to be negative 9x cubed. Okay, they're combined. Then I have no x squareds, and then I have just these this minus 4x term, nothing to combine it with, and then I have a constant, which is a negative 4. Okay, and remember we talked about standard form where we write largest exponent and then in descending order. Okay, so for subtraction though, this is where you have to remember we add the opposites. So this polynomial we don't change, everything stays as is, but this, since we're subtracting this whole quantity, I need to change everything to its opposite, and then this becomes a plus sign. So we're really going to add a 3x cubed. Then I'm going to add a 7x squared, and then I'm going to subtract an 8x to the fourth. Okay? So once again, we'll start with the largest, which is the x to the fourth. These cancel out. Okay? So really it's 0. So you could say 0x to the fourth, or simply don't put anything there. Okay? But x to the fourths are gone. Then I look for my cubes. I have 4 plus 3 is 7 x cubes. They're gone. My x squareds, we will end up with 1x squared. Okay, you can put a 1 if you want, or just simply say plus x squared. The x squareds are gone. And that's all my terms. Okay, we don't have any x's, we don't have any constants. So really, the final answer is just a binomial, 2 terms. Okay, so that's how we subtract. The key to subtraction, add the opposites. Okay, and we're going to quickly review multiplying. This is FOIL, so when it's a binomial times a binomial, we learn to take 12m squared, that's your first. Your outers is going to be a negative 36m. Inside's going to be a minus 16m. And then 8 times 6 is going to be 48. And then we can simplify the middle terms. So the negative 36m and the minus 16m together, it's going to be 52m. Okay? And then this one, negative k times, just so be careful of your signs. A negative times a negative is going to be a positive. So we have k squared. And then I'm going to have a negative 3k. This will be a negative 14k. And then finally a 21. And then we simplify. Okay, so it's very important that you can multiply, because factoring is going in reverse. So you always, when we factor, you still need to know how to multiply to be able to check your answer. Okay, so that's the first page. Okay, now you're not going to have quite as many on your test, but we should get good at being able to multiply very quickly. Okay, 5 times 5 is 25, and it'll be b squared. Here we'll have a 35v. Inside we'll have a negative 15v, and then a negative 21. Okay, and we'll simplify this 35 minus 15. That's going to give us a 20. And then we have the minus 21. Okay, so get a trinomial. Here, 8 times 7 is going to be 56. So 56 k squared. This will be a negative 16k. This will be a negative 7k. And then a positive 1. Okay, negative 1 times negative 2. And what you're going to then do is combine your middle terms. the k's, that'll become, the middle right here becomes a negative 23k plus 2. Okay, you can fly through these. This one is going to be a special case because you're going to see that your outers and your inners are going to cancel out. So I'll show that, but you have 20 of them, and then we're going to take away 20 and right away, and you have a minus 16. So it's a 25n squared minus 16. Okay, and we just recently talked about factoring. If you have a perfect square minus a perfect square, how easy it is to factor, to go in reverse. Okay, here we have our 9, but our outers and our inners are going to disappear. These cancel out, and you're left with a minus 36n squared. So final answer is 9 minus 36n squared. Again, a special case. Okay, so now we have to remember, when you square a binomial, you always get a trinomial. Okay, in fact, you get a special trinomial that's super easy to factor, but I'm going to show you the long way for this one, then I'll show you that shortcut, the square double square method. But the safe way is just to write it twice. That's what it means to square, itself times itself, and do FOIL. So you're going to have 64n squared. We have a 40n plus a 40n, and then plus 25. So this right here is an 80n plus 25. Okay, so outers and inners will give you the middle term. So if you don't want to write it out twice, you can square double square. So that's really what I did here. I squared the first term, 64. I multiply what's inside and double it. So 40 doubled is 80, and then 5 squared is 25. So I'm going to do the same thing here. This squared is 4x squared. I multiply what's inside, it's just a 2x, but I double it for the middle term, it's a 4x, and then 1 squared is just a 1. Okay, so if you feel confident, you can write your trinomial, square double square. I would on the test write it out though, write your binomial times a binomial and multiply. Okay, now we're gonna go to some factoring problems. Okay, so the first type of factoring we did was GCF. So that's what I have you starting with. Look for the largest number that divides into a 14 and 18, and in this case it's just a 2. And whenever you have a variable in common, you can factor out the smallest exponent. So really all I can factor out is a 2x. Okay, that's what's in common between these two terms. So in parentheses, I'm going to have a 7x to the 5th, because 2x times 7x to the 5th gets us back to the 14x to the 6th, and then I need a minus 9. And we're done. Okay, so again, always check by multiplying, and you're good. For this, only number that fits into a 7-4 is a 1, so you only have an r in common. So all I can do is factor out an r, but then we'll have a 7r squared plus 4 inside the parentheses. Okay, so again, if you distribute the r, you're back to the original problem. Okay, so GCF, always look for GCF. Okay. So we're factoring each completely. I remind you to always look for a GCF, and these should be very easy. So these right now are what we just learned, the difference of perfect squares. So if you recognize, and on my sideboard I have a list of perfect squares, what times itself is 81, it's going to be a 9. So 9n is going to appear in both sets of parentheses, and then what times itself is 64, it's going to be an 8. So we need a plus 8 and a minus 8, and we're done. 9n times 9n is the 81n squared. Outers and inners disappear, and 8 times negative 8 is negative 64. Here is just going to be 10 plus 3 and a 10 minus 3. That's how long it should take you if you recognize a perfect square minus a perfect square. Now this one, I need you to realize there's a GCF first. We can factor out a 9. So if you factor out a 9, should have been obvious that 9 fits into both. Oops, this is supposed to be a 1. So let's fix that. Got to divide by 9. So 100n squared minus 1, they're still both perfect squares. So I'm going to keep the 9 out front, 2 sets of parentheses. This will be a 10n, because 10n times 10 is 100n squared, a plus 1, and a minus 1. Okay? And then this one, we are dealing with just factoring trinomials. So regular trinomials. This one happens to be a special one. That's not too hard to find, but we know everything's positive. So plus, plus, and a way of getting 49 to add up to a 14, we're just going to have 7. Okay, so x plus 7, your outers and inners will agree with that middle term. Okay, here again, all pluses. So these are the easy trinomials to factor. There's no GCF. You always should look for GCF. And you're thinking ways of getting 15. So if you want to make a little diamond, you can. So 15 and then an 8. That's what I'm trying to find to figure out these pieces. And 15 and 1 won't work, but a 5 and 3 will. So it doesn't matter the order. If you want your 3 first, then the 5. Doesn't matter, it will check and get us back to the original. Okay, so I'll have some easy trinomials for you on your exam. This one, it doesn't look easy at first until you recognize 6 fits into everything. So always look for a GCF. So if I factor out a 6, then this becomes a really easy problem. Okay, and if you need to use a calculator to show that 54 divided by 6 is 9, use your calculator. But then I'm going to factor this easy trinomial. So this time, since this is positive and this is negative, I know it's minus minus. Okay, and ways of getting 9, 3 and 3 won't work, but a 9 and 1 will. And that's the pieces we need. Okay, so outers and inners will agree with the negative 10. Okay, here, this is that AC. This is the hardest, the most work that's going to be on your test is when, and this is what we were spending so much time on big ideas in that 4-6 assignment, trying to get you to set up the problem. There's no GCF, but A times C. So in this case, negative 60n squared, and I need it to be able to give me a negative 4. So the two numbers I come up with that give me the negative 60, they have to add up to a negative 4. So you can just start like 60 and 1. That won't work. 2 fits into 6, so I'll do 2 and 30. And then 3 goes in 20 times. Again, I still can't get a negative 4 out of that. 4, so you just take your calculator, start dividing. It goes 15 times. And then 60 divided by 5, that's 12. So 5 and 12. Again, I still can't get that negative 4. The difference is not negative 4, so I'm going to keep trying. And then eventually I'm going to see, and maybe you saw this right away. I'm just trying to show you systematically how we can go through this, but 6 and 10. So if I have a negative 10n and a positive 6n, that satisfies this diamond problem. Okay, so once you satisfy this part, you're going to go back to the original problem and replace the middle term with what you found. So what we found was a negative 10n and a positive 6n. So I replaced that, everything else stays the same, and we split it down the middle. So on this left side, the only thing in common is the letter n. So I'm going to have a 3n minus 10 once I remove an n from each of the terms. What I like about this technique, though, is what's in parentheses must appear on the other side. So what's in common on this side is a 2. So if I put the GCF on the outside, I now have my answers. The pieces on the outside, the n and the positive 2, is one of your factors, and the 3n minus 10 is the other factor. And if you did FOIL, you're back to the original. Your outers and inners is what we found. A 2 times negative 10 is negative 20. Okay, so expect 1 or 2, and I'll try to make it so that it works out very nicely for you. Okay, so let's take a look at this other one. AC method. AC. I'll try not to have any outrageous numbers for you. So negative 56n squared to add up to a 10n. So once again, I'm going to start going through 56 and 1. That's not going to work. But if I divide by 2, I get 2 and 28. Not going to get a 10 out of that. 56 divided by 3. That doesn't even fit. I'll try 4. 4 and 14. And when I see the 4 and 14, since this is negative, I can use a positive 14n, and a negative 4n. That satisfies that diamond. So that's where the most work's going to be, just to try to figure out what makes that diamond true. Okay, so now I'm just going to take this, replace the middle term with a 14n and a minus 4n. Now you can switch these, still going to work out. So I split it down the middle. On this side, I have a 7n in common. So n plus 2 is going to be what's inside the parentheses. That's why it's so important that you can understand how to factor out a simple GCF. I must have an n plus 2 on the other side. So that means I need to factor out a negative 4. Because negative 4 times n is negative 4n. Negative 4 times 2 is negative 8. So now I have my answer. 7n minus 4 and n plus 2. There's your answer. Okay? So, before you do A times C, recognize that everything is even. So if everything's even, I know I at least have a 2 in common, and that is our GCF. 4 doesn't fit into a 10. So I'm going to factor out a 2 first. That's going to make this problem easier if I recognize that. So I factor out the 2. So my answer is going to be 2 times something times something. So now I'm only worried about 5 times negative 7, which is negative 35, and I need to come up with a combination. Okay, so in this case, my brain already told me I know 7 times 5 is 35, and so if I have a negative 7k and a 5k, it's going to agree with the negative 2k. Okay, so I'm going to replace the middle term with a negative 7k and a 5k, and I'm going to split it down the middle. So I'm going to factor out a k, 5k minus 7, 5k minus 7 on the other side, and really the only thing I can do is put a 1 on the outside. That's the only thing in common on this right side, but I put the k and the 1 together as one of my factors, and the 5k minus 7 as the other. Okay, so that checks. So then the last part of this is just to remind you that we can solve equations by factoring. Okay, solve each equation by factoring. It must be equal to 0. So the first two are equal to 0, so we just factor. So in this case, it's an easy trinomial to factor. It's x and x, a plus and a minus, and I know 6 and 4 is going to give me the negative 24, and I must have the 6 next to minus, the 4 next to the positive, so that it adds up to the negative 2x. Okay, so once you look at the factors, though, we use that zero product property that says, what makes this factor 0? So x plus 4 equals 0, well, that's just going to result in a negative 4. So one of my answers is negative 4, and the other answer is a positive 6. And one way of checking your answer is if we go to the y equals screen on our calculator, we can type in the original problem. So this is how we can check. I need to see the factors though, but I can check by graphing. I'm going to see it crosses at negative 4 and positive 6. So your x-intercepts end up being our solutions. Okay, and that always works. Here, all we can do is factor out an x. So you factor out an x, you're going to have 0. What makes an x 0 is 0, and a negative 6. Again, you could type that in and confirm those answers. Okay? So then for this problem, we must add that 4 so that we have 0. So you must have 0. So I'm taking that negative 4, bringing it over to the other side, and now I have an AC problem. So I have a 28k squared negative 16k. So both these are going to be negatives. Okay, so my brain already started working. It's going to be a negative 2 and a negative 14k. Okay, because negative 2 times negative 14 is 28, but then they add up to negative 16. So what we're going to do is simply replace the middle term and split it down the middle. Okay, so k is what's in common on this side, 7k minus 2. On this other side, I'm going to have to factor out a negative, and what you're going to see, if I write what's in the parentheses on that side, I know it's going to be a negative 2. Okay, so negative 2 times 7 is a negative 14k. Negative 2 times negative 2 is 4. Okay, so k minus 2 is a factor, and 7k minus 2 is the other factor. So then what makes this 0 is a 2. Now, this one's going to result in a fraction. We did this in Big Ideas. If you can't solve that in your head, off to the side, set that factor equal to 0 and realize it's a two-step equation. You're going to have to add a 2 and divide by 7. That's where I get 2/7. Okay, so 2 over 7 is the solution. Okay, last one. It's going to be a 2a squared minus 3a minus 20 equals 0. Okay, so we're going to make a diamond. I'm going to have a negative 40a squared and a negative 3a on the bottom. Ways of getting negative 40 to add up to a negative 3. My brain already knows a negative 8 and a positive 5. Okay, that satisfies the product. Negative 8 times 5 is negative 40, and the sum, add them together, you get negative 3. So 2a squared minus 8a plus 5a minus 20 equals 0. Split it down the middle. Factor out, in this case, your a. So if I factor out a 4, or excuse me, I can only factor out a 2. I started talking before I wanted to. So it's going to be a 2a I can factor out, and this will be a 4. Okay, so a minus 4 is in the parentheses, so that means I must have an a minus 4 on the other side, which means I factor out a 5. Okay, so the 2a and the 5, that's a factor, and the a minus 4 is the other factor. So one answer is going to be a nice 4. The other answer, I have to subtract a 5 and divide by 2. Leave it as a fraction. Okay, so that took a little over 20 minutes. You don't have near that many problems on the actual exam, but these are good reference problems that you can refer to while you're doing your exam. So please make sure you get all these down. You'll hand in this paper. I'll give you credit for doing this paper. Fix any mistakes. Fix it by watching this video. Care about this, and you can do well on the Chapter 7 exam. Thanks for watching. Take care.